Hey everybody, and welcome to our Twitch session for today. Myself and Ryan are with you. Welcome to the Aws Iot App Challenge kickoff. Ryan, how you doing?
I'm great. How are you doing, Mark?
Yeah, I'm awesome. It's a nice early, dark, cold spring morning in Melbourne, Australia.
It's a little early in Australia. Yeah.
Yeah. It's
a nice afternoon in Seattle.
Fantastic. Nice and early here, so I got my cup of coffee with me. Thanks for joining us, guys. We're going to do a couple of things over the next hour and a half or so. Ryan and I are going to spend some time with you talking about the Aws Iot App Challenge kickoff. I'm going to take some time and walk you through a piece of code that we've got for you to assist in your development efforts that you're doing with the challenge. This piece of code is called WeatherGen. I'm going to run you through that, and really it's a traffic generator that spits out weather-related data for you guys to consume. You can run that on an EC2 instance on the AWS platform. But you could also take that code and run it locally on your laptop. It's a Mqtt stream producer, and we'll talk about what that means a little bit later. And we're going to run you through that, and we're going to do that top to bottom. So we're going to go through looking at the repo, which is sitting in AWS Labs. That's our place where we keep all our publicly accessible code. We're going to have a look at how you pull that down. We're going to look at how you can use things like CloudFormation to fire up an EC2 instance and bring that code live. And we're going to dissect the code. We're going to have a look at some of the streams. And along the way, we can have a bit of a conversation around what that means from an IoT perspective and how you can consume that data within the work that you're doing. And then what I'm going to do is hand over to Ryan, and Ryan's going to do a little bit of work with you guys around Kinesis. Do you want to give us some insight, Ryan, into what you're going to be doing?
Yeah, so we're going to go through another way to sort of ingest and mock data into AWS IoT and an Amazon Kinesis stream. We'll also use some other options for writing directly to Kinesis streams and fire hoses to help you guys out with testing various pieces of your solutions. We'll also go through some real-time SQL queries, and I'll give you guys some ideas on some things you can do with both Kinesis Analytics, AWS Lambda, and some other services. But at the end of it, what you'll basically get is an end-to-end application which ingests data via AWS IoT, and then provides sort of real-time analytics, and then provides some visualization. And I'm going to go through one example, but as I go through those examples, I'll talk about some various options of other AWS services you can use during the process. So it should be fun. I think the whole session should be about an hour and a half, maybe 2 hours, Mark, right?
Yeah, I think that's about right. I guess we're happy to take questions along the way so we can address those. So yeah, let's see how we go, Ryan. I reckon it's going to be really cool. But before we jump into the good old geeky stuff, let's talk a little bit about the AWS IoT App Challenge. So this is an awesome program, and I'm sure most of you guys out there joining us at the moment are hopefully going to take part in it. And really what this challenge is about is to ask you guys to go out there and build some apps and build some code that allows you to collect and process sensor data. And we want you guys to identify some problems and try and solve those problems that are out there. So it could be anything from things like how do you ingest data around ordering of groceries, automating requests for changing printer cartridges that might be out there, or collecting data from industrial IoT applications. You've got to be using three key things. Of course, you've got to be using the AWS platform, otherwise we wouldn't be here today, I guess. We really want to see you guys also out there using AWS IoT services, and that's what I'm going to be focusing on in today's Twitch session. And we want to see you guys do some amazing stuff with Amazon Kinesis. So we really want to see some innovative thinking and get out there and show us what you can do. There's some awesome prizes that are out there. we've got a prize pool of $10,000. We've got some Amazon Echoes to go. We've got AWS credits. There's a whole bunch more. So this is really the start of what is hopefully going to be a great experience for you guys out there. So I'm ready to jump into it. Ryan, what do you reckon?
I'm ready to jump into it as well.
Sounds good. All right. So what I'm going to do is I'm going to jump across to the AWS Labs GitHub repository. So for those of you who are familiar with Git, this may be a little laborious, but for those of you who are not, Git is a distributed version control platform that allows you to maintain code and to distribute that code to a broad community and to manage changes to that code. And what you can see here is the AWS Labs WeatherGen page. And the software that we're going to look at today is really a starter kit for you guys to be able to take a range of sensor data and to have that data published onto arbitrary Mqtt topics. I'll touch on Mqtt as we go along, and we'll do a bit of a deep dive on that. And then you can take these streams of data and you can consume them and ingest them into the AWS platform. Why have I chosen to use weather data today? Well, weather data, I think, it's quite topical with all the discussion around climate change, looking at all the unfortunate news about what's gone on in Florida and other places around the US. I think this is really a topical piece of information to have a look at. But the code that I'm going to present to you today can really be modified to stream any sorts of data. So let's start by having a look at the structure of this repository. So what you can see here at the top of the repository is, and most importantly, this generate.js application. And we'll have a look at this in an editor shortly. But this is the application that generates the data and pushes it onto an arbitrary MQTT stream. What we've done in this weather data generator is we've focused in on streaming data around four key environmental pieces of information. That is rain, and we're pushing out rain data, and that's measured in inches per minute. We're pushing out temperature, measured in degrees Fahrenheit. We're also pushing out vibrational data. So those of you in earthquake-prone areas or interested in seismic data, that's one piece of data you can hook into. And we're also sending out wind speed data. Now, the wind speed data is an interesting one in this application because it is a vector. The others are all straightforward, either integer or float values, but wind speed actually sends two pieces of information. It has a direction, which is measured in degrees from north, and it has a magnitude measured in miles per hour. So they're the four pieces of data that you'll receive on this stream. Now, what are we using as our source?
Hey, Mark, just a quick question. Just the weather data generator, what are some differences that you typically see from sort of this mock data and sort of a real IoT sensor? How is it similar or dissimilar?
Well, we've been a little bit sneaky here, Ryan. What we've done is we've worked with our friends at Forecast.io and darksky.net, and when we fire up the generator application, we actually go and make an API call, and we get the weather data from a location that you specify in the command line, and we get that data from 24 hours ago, and we'll stream that data to you. So it is actually real data from 24 hours ago, which is pretty cool, right?
That is really cool. That's pretty awesome. So this is very typical of what you'd see from an IoT sensor.
Absolutely, absolutely. It really is a real-world stream of data. So that will give you guys out there the ability to do some real calculations. When we step through the code, Ryan, what I'm going to show you is that the data we get from these APIs is not as granular as we would like it, which means that there's some gaps in the time frame. So we want to send data out on these streams about once a second. But sometimes that's too regular for the data set that we actually get. So we use some interpolation between those data points, and we make some pretty intelligent guesses around what that data might look like between those data points that we actually get from Forecast.io and what we push out on the stream. But ultimately, the stream of that data is based on real-world information.
Very cool.
There are a couple of things that you're going to need out there to kick this off, and one of the key ones is an API key. So before you get started, go out and register, get an API key. The link is there to go and fire off a request for an API key. It is free for the data that we're using, so you can just go ahead and register, and you'll get an API key, and I'll show you where you can put that key when we get started. Now, of course, we can run code on our local development machines, and we're going to geek out on that shortly. But we can also run the code that we're providing on AWS EC2 instances, which is our compute platform, Elastic Cloud Compute Platform. To make that easy for you, we've provided a CloudFormation template and some helper scripts that are going to stand up a virtual private cloud, a VPC, which is your own walled garden within the AWS public cloud environment. It's going to configure the appropriate security for that virtual private cloud. It's going to fire off a EC2 instance, and it's also going to install all the prerequisites required for you guys to get started. So this is just a great way to really kick things off, and we're going to step through that CloudFormation template. One of the cool things about having this in CloudFormation is you may want to have multiple streams representing multiple locations. So Ryan, what you could do is you could have a stream of data represented for Los Angeles, a stream of data represented for New York, and the EC2 instances are going to be generating this data, one EC2 instance per location. If you run this stuff on your laptop, of course, you're going to close the lid and you're going to walk away. You might turn it off, and those streams will stop. If you've got embedded devices or something like a Raspberry Pi out there consuming that data, your application will effectively stop because there's no source data anymore. If you use our CloudFormation template, we rely on EC2, they're going to stay up regardless of what you're doing on your development environment. So it's just a great way to continually stream data throughout the life cycle of your project. So we'll look at the CloudFormation. We'll also talk about how you do this from a local installation standpoint. We're going to use Yarn today, which is a package manager for Node.js from our friends at Facebook. But you could also equally use NPM if you're more comfortable with that. And I'm going to run you through what the command line parameters are in order to get this kicked off. That's a great point. Yep.
So, Mark, just to jump in real quick. So Mark's showing one way to use CloudFormation to spin up a portion of the application. But one of the things that we're going to encourage as part of your guys' submissions is that you also use CloudFormation. It makes it a lot easier for you guys to package and more people to use it, as well as it makes it easier for us to test. And in general, as we would like to share your guys' solutions, it's a lot easier if they're packaged via CloudFormation. Definitely not a requirement, but it's something that we'd encourage you guys to do broadly as you guys develop your solutions.
Yeah, absolutely. One of the great things about CloudFormation is that it makes your deployments onto the AWS platform consistent. And it allows you to stand up and tear down what we call stacks, which are effectively stacks of resources. They could be EC2 instances, they could be Kinesis streams, they could be SNS topics. It allows you to stand those up in a consistent way and then to tear them down again when you're finished. And we're happy to take questions on CloudFormation, I guess, as we go along if it's new for some of you. But it is really a great way to really stand up that AWS infrastructure, to do that consistently, and to enable you to stand it up and tear it down on an as-demand basis. So, excuse me, let's jump into what this code actually looks like. So I'm using an editor here, Visual Studio Code. It's my favorite editor. I've got lots of different plugins here. If you want any more information on these, let me know. The first thing we're going to have a look at here is the config file. And you'll notice here in the config directory, we've got this file called config.js. This config.js really just defines two key objects that we use throughout the application. The first one is the Mqtt configuration, and it enables us to fire up the Mqtt server, which is going to be streaming out the data and provide some configuration elements. Unless you're doing something really funky, which we always encourage you to do, you probably don't really need to change this part of the configuration. The key element here in the configuration is the API key. And you'll notice here there are two parts to this, or two members to this forecast object. The first one is the API key, and the second one is the URL. In the code base, we've included a link where to go to register. So let's just go and have a look how we would get an API key. So let's jump across to a browser. I'll open up a new tab, and this is really straightforward. So we jump across to Dark Sky, and we just register. Within there, you'll get an API key that you can copy and paste into the configuration. Now, for today, I've just kept a copy of my API key. So I'm going to copy that API key. Now, you're all going to see it. I just encourage you not to actually use it. It's not included in the repository. I encourage you all to go and get your own, because there are some limits into the amount of calls that can be made within the free tier for this API. So what you can do once you've received your API is just copy the API key into that section of code and replace all those XXXs within the object. And that's basically all that you'll need to do to configure the code to run. Now, of course, we are running a Node.js application. So jumping across to the console, if we have a look at the code base, you'll notice in here there is a node modules directory. These node modules are the third-party dependencies that this application relies on. And those third-party dependencies are expressed in the package.json file. So let's have a look at that package.json file. It's a standard package definition, and you can see here there's a number of third-party dependencies linked in here. And what we'll do here is we'll use a package manager called Yarn, as I mentioned before, and Yarn is going to bring in those dependencies. When you clone this repository, you'll actually notice that there is no node modules directory already there. So if we jump across to what that repository looks like from the ground up, there is no node modules dependencies in here. So what I'm going to do, just to show you how to do this installation of the dependencies, is I'm going to remove my local node modules directory. And you know, Ryan, I always get a bit nervous when I do this rm-rf command. I've done some pretty horrible things with that before, so I can just make sure, guys, that you're in the right directory and that you're deleting the right thing. So I'm going to delete all those node modules from my local machine here. And you'll see here from my ls, I'll just clear my screen so you can see it, that's gone. And what we can do here is we can just go yarn install. That will go in and read the package.json directory and will pull in all our dependencies. You could do exactly the same by using npm install, the node package manager, and it's really up to you. If you're using CloudFormation, the CloudFormation scripts that we've provided, this will be done for you in the EC2 initialization. We'll have a look at that as we go along. But what you can see here is I'm pulling down all the third-party dependencies. It does take a minute or two, but once you've got them, the only thing that's required is to keep them up to date if need be. But again, if there's no new features or functionality you need in later versions, you can probably just stick to the versions that are defined in the package.json file. So 47.88 seconds later, 47 seconds of our lives we'll never get back, especially listening to me rattle on. You'll notice here we now have a node modules directory. And if I look into that node modules directory, here are all the third-party dependencies that our application requires. So what we've done so far is we've got an API key that we need to make those calls out to the dark sky or weather or forecast IO API, and we've installed our third-party dependencies. So from a local perspective, we're pretty much ready to go. So what I'd like to do is, before we get going on the local machine or my local development environment, let's go in and have a look at these CloudFormation templates that we've provided you. You'll still need to do the configuration steps that I've just mentioned in terms of getting an API key before you get started. So we'll talk about that once we fire up the CloudFormation stack. What you can see here is we've got an AWS directory at the top of our project. Within the AWS directory, we've got a CFN, which is kind of a short form that we use for CloudFormation. I've got a stacks directory, and inside there I've got a WeatherGen stack directory. And I've got 3 shell scripts in there and a configuration file as well. The first shell script is called create, and this enables us to create the stack. I've got another one called delete, which enables us to delete the stack when we're finished. And I've got an update, which if we have any changes to our CloudFormation template, we can just issue the update command and it will go off and update the stack and add any changes or remove resources, etc., according to the changes we've made in our stack. The config file is pretty simple. It enables us to define a name for the stack. We're not using S3 buckets for this. We're doing an upload directly from our local machines, development environments to the CloudFormation engine. So we don't really need an S3 bucket, but if you wanted to update these scripts, you could reference that S3 bucket variable to your own, where you may have additional metadata or additional config, etc., that you might want to pull in to your CloudFormation template. Here I reference a bucket, which is a object store, and this is where I keep some of my Lambda function definitions. And of course a region, and a region is the AWS region. You can run this code in any region that you like. There won't be a problem there. We're not using a huge amount of services. So you should have all the service availability for everything that you need in the majority of the regions. The create script is very simple. We pull in the config, and then we basically issue the AWS CLI command, AWS CloudFormation create stack. We give that stack a name. We tell it where the template body is, and that's a JSON definition. We also support YAML. I don't know, what do you prefer, Ryan? I'm a bit of a JSON guy because I'm a glutton for punishment.
I definitely prefer JSON.
Yeah. Me too, but feel free to use YAML if you're comfortable with that. And we also pass in a region. So this is going to create our stack on the AWS platform and deploy all the resources that we've asked or that we've defined in our stack.json file. So I'm not going to go through everything in this JSON file, but you'll notice in here we define a range of resources. For example, we define a VPC. That VPC has a set of properties like what block of IP addresses do you want to give it? What CIDR block is available within that VPC? We also give it tags, and tags are really cool because it enables us to group resources, to search for resources, and even to go through our billing, for example, from AWS and have a look at what resources have consumed what component of our cost. And we define things in the... Yeah.
I got one comment and one quick question. So one of the things that I like to do, everybody, and since there's a lot in this CloudFormation template, it's actually hugely helpful, is just to run this script and then go to the console and watch the CloudFormation template get generated. And then you'll be able to see all of the resources and their steps getting generated and sort of get an overview of what the template's doing. I find it hugely helpful. So it's one way to walk through sort of what the template's doing, in addition to see like what you change in the JSON or your YAML file how it impacts what the CloudFormation template, and whether it was successful in the creation of the entire stack.
Exactly.
So one comment, and the second question is, we have I think Mark answered the question. So Lyle Davis had a question on shell scripts generator. Do we need to create them? And they're provided in the Git repo. That's it, Mark. Back to you.
Yeah, exactly. We want to make this as easy as possible for everybody, Ryan. So we've done the heavy lifting for you, guys. So if you go to this URL, I'll leave that up here for a moment. All these scripts are provided in the AWS CFN stacks weathergen directory. So you will not need to create any scripts. Everything is provided for you, guys. We try and make this as simple and quick as possible for you to get started. And I think, Ryan, your input there was really good around having a look in the console and seeing what CloudFormation is actually doing as you're standing up your stack. So I'll just point out a couple of extra things before we do that. You'll notice in here, and I've just collapsed some of these objects, we're defining some resources like VPCs and route tables and default routes, and we're associating subnets to a route table, and I can talk about what that means if you guys have any questions. We attach some elastic IPs to our EC2 instances. And here you'll see our definition for the EC2 resource. And this resource type is an AWS EC2 instance. And in here we define an image ID, which is an AMI. And the AMI is an Amazon machine image. We're using a standard Amazon Linux image here. You guys can feel free to change that and to use a operating system that you're comfortable with. One of the great things about deploying Node.js code is that it's really, really portable. So you could use Ubuntu, you could use CentOS, you could pick another publicly available AMI, but if you've already got an AMI that you use, you could also leverage that. And we define what AMI we're using up here in our parameters. So you'll see here there's an AMI parameter defined, and I defaulted to this AMI ID, and this here is the Amazon machine, the Amazon Linux AMI that we're going to deploy, and we're deploying it on a T2 micro. So that's a pretty small but really useful instance type. It's a burstable instance, and because we're not very CPU heavy and we don't need an incredible amount of CPU, we just want to stream out some basic data. T2 micro is a great choice, very, very cost effective. I think these end up, if you're running these, they work out to be a few dollars a month to run. So that's just a great instance type. So what I might do is open up the AWS console, log in, and we'll open up the CloudFormation screen. And you'll notice in here I've got a bunch of other stacks deployed. Obviously, we're pretty busy with stuff here at AWS. But you'll notice I don't have a weathergen stack created. So I'm going to show you guys how you can really bootstrap this very, very fast from an EC2 perspective. So if you go into the AWS CFN stacks weathergen directory, and we have a look in there, there's our create, delete, update, our configuration, and our stack definition. All I need to do to create this stack is just go create.sh. And that's going to use the AWS CLI. So if you don't have the AWS CLI, we'll post a link in the chat window about where you can get some help for that in terms of installing it. It is really a fantastic way to interact with the AWS platform, and everything you can do in the console, you can do in the API, in the CLI. This is because we're an API-first company, and everything we do is accessible via APIs and CLI. So you can see here, I've told the AWS platform to go and stand up this CloudFormation stack. Now, if I jump back into the console, you'll notice over here, I've now got a weathergen stack that's being created, and it says create in progress. I think this is what you were talking about, Ryan, yeah? To be able to jump in.
Yeah, exactly what I'm talking about.
Have a look at what's going on. You'll notice here there are some outputs, resources. what I'm going to do is just have a look at the events. And you'll see here those resources that I was talking about before. You can track how the progress of your stack creation is working and what is currently being processed. So you can see here that AWS EC2 instance resource that I was talking about before is currently being created. So this is a great way to keep track of how your stack is going. Error messages are also shown in here, so if you need to go back or you're troubleshooting, this is a great place to get all that information. As resources are being created on the AWS platform, you'll see them turning up in here. So you can already see we've got an EC2 instance. It's just finished being created. We've got an instance ID. We've got an elastic IP that's been allocated to it. And of course, we've stood up an internet gateway. Internet gateways are required in VPCs in order to access the internet. And you can just see here the range of resources that have been created. What I do want to show you is that it's easy in the console to jump between the various different services. So you can see in here, we've got a link to our EC2 instance that's being created. So I can click on that and we open up a new window to the EC2 manager, and straight away we can jump in and we can see that that T2 micro that I was talking about has been created. The instance is running. It's got a public DNS, but it's also got a private public IP address. And you'll notice that we've also got security groups attached to this EC2 instance. So a security group is really a wrapper around AWS resources that enables you to define, enables you to define things like ports, protocols, and source addresses to control traffic ingress and egress from resources. And you'll notice in here I'm allowing port 80. We're allowing that. You guys might want to put a little web server on this instance to serve some extra data for your application. We're allowing port 22, which is SSH, but we're also allowing port 1883. Do you want to take a guess what 1883 is, Ryan?
Say again, Mark?
Do you want to have a guess what port 1883 is?
You go ahead.
Oh,
no guess.
Yes, I caught him out. I'm happy with that one. That's few and far between. 1883 is the MQTT server port. So that enables our MQTT clients that are sitting out there on the internet or in the real world to access this EC2 instance to receive those MQTT streams.
Thanks for calling me out, Mark.
Oh, I love it.
Just a quick message for those that have joined us, since we've had quite a few people join us since we started the broadcast. This is for the AWS IoT App Challenge. Chandler, under Mqtt Fx EHC, has posted sort of where you sign up and register for the challenge and the GitHub repo that Mark is going through. And Mark, if you could just give a quick overview for those that joined a little bit late about where we are in the process.
Sure, no problem. Thanks for joining, guys. Awesome to have you if you've just joined. We're running through two key areas today. I'm covering off a tool that we've built called WeatherGen. This is a MQTT stream generator that you guys can use to generate, funnily enough, real-world weather data, rainfall, wind speed and wind direction, vibrational data, and temperature. We're showing you guys how you can stand this up on an EC2 instance in a VPC. We're also showing you how you can stand up this code and stream the data from your local laptop. And we're going to do a deep dive onto the code and get really geeky. And then sort of when I've run out of steam on this, Ryan's going to pick up and run you guys through how you can take this data, process it using some of our streaming tools. Ryan, do you want to give the guys a quick update on what you want to cover off?
Yeah, so what Mark is showing is, what I'll be showing is a little bit different is, instead of using a CloudFormation template, I'll be showing how to interact with some of the Amazon Kinesis services by hand using the CLI as well as the console. And I'll be showing how they interact with the AWS IoT services. It's really simple to set up. And I'll be showing some different types of sort of processing you can do on the streaming data as it comes in. So we should start that in probably like 20 or 30 minutes, I think. Right about Mark?
Awesome.
Yeah.
All right, guys, keep the questions streaming in as well. Love to see the questions and the discussion happening. It's awesome. One thing I do want to point out is if you're firing up EC2 instances on the AWS platform, one of the things that you need to provide is a key pair name. These key pairs are generally used to access instances and to provide a level of security around that access. The CloudFormation template that we supply, which is this one, we touched on this before, includes a number of parameters. And these parameters you could really view as variables that get defined. One of them is the key pair name. Now, of course, I'm deploying this, so I'm defining a default key pair name, which is my surname, AWS-own, which is one that I use. You may need to create your own key if you don't have one, and you probably want to modify this because you don't have access to my key. One great thing about the AWS platform is it will not allow you to access things that you do not have permission to access. So you'll need to create your own key. If you need some help on that, we can post some links as we go along. But I'm using my own key here. Please replace with your key if you want to use the CloudFormation template. What I'm going to do is jump onto that EC2 instance. I've got a public IP address over here. I've just done a copy and paste. So I'm going to go back into my Geek Out screen, and I'm going to SSH into that instance. So that's a secure shell, pretty stock standard. I'm going to SSH. I'm going to use the standard EC2 user name. I'm going to pop in the IP address, and I'm going to provide a -i, which allows us to define which key we're going to use for this identity. Now, I happen to keep all my keys locked away in my home directory /keys, and over here I can just specify the key, and of course I can't see what I'm doing properly, so let me open this up. I'm going to get the right key, which is this one, and I will be able to log in. So off we go, and here we are. So I pop into the top directory, and you'll notice in here that our CloudFormation has even gone and brought in the latest code for us on this EC2 instance. So I can go straight into this directory, and you'll notice here we are on this EC2 instance. As we said before, we want to run yarn install. This will resolve our packages, and have a look at this. We're already up to date because we've provided some initialization code in our CloudFormation template that already updates this instance with the latest packages for this application. So that's pretty cool. Let's have a quick look back into the CloudFormation around how we do that. We'll just look at that very quickly, because if you guys want to modify your initialization on these EC2 instances, this is where you'll want to do it. So when an EC2 instance fires up, we look for something called user data, which is supplied to the CloudFormation engine in base64 encoded format, but you can supply it by just your normal command line. So what we do when this instance fires up is we make sure that we're running our bash shell, we run some updates, we bring in yarn, you can see that here on line 188, we set some repository information, so we get the latest version of Node.js, and then we go ahead and we install Node.js, yarn, and we install Git. Why do we need Git? Well, because our code is sitting in a repository. So for those of you who aren't familiar with Git, you can use this git clone command and this URL to clone that code onto the EC2 instance. When we're finished with that, we change directory into that new repository that we brought down, and I just do yarn install. So that's really cool. You guys don't have to do anything. The application is there and ready for you to go. What do you reckon, Ryan? Pretty cool, huh?
It is pretty cool, nice and quick.
Nice and quick, and we're up and running. But as I mentioned before, we need to bring our API keys in. We don't have access to your API keys. So on the EC2 instance, we can change directory into our config, and we can just paste in to our config.js that API key. Now I'll just jump across, I'll copy the API key that I brought across into my local configuration earlier, and we'll paste this into the config.js, and of course I'm not running as the right user. Typical. We'll jump in and we will put our API key in. That will give us access to the dark sky or forecast IO API. If you don't do that, you will get an error that's pretty self-explanatory. It says it's an invalid API key, so keep your eyes open for that. And that's it. We're configured and ready to go. So what I want to do is walk you through the command line, how we fire up our instance. So, not our instance, sorry, our application. So we'll jump across to the Git repository again. And in here, we step you through the CloudFormation as we've just done, but we also run you through how to actually run the code. So if we look at the command line, you'll see here we're calling generate.js. We provide a state, and the example I have here is California. We define a city. Palo Alto is one of my favorite cities in the US. I just wish I could afford to live there. Apparently every time there's a new Silicon Valley IPO, prices in Palo Alto go through the roof even further. So yeah, I don't think I'll ever be fortunate enough to live there, but I do love it. And then we provide the longitude and latitude of that location in the longitude and latitude options, and we provide a sensor name. And I've just given this in this example sensor 1, but this could be any arbitrary name. So just to get this running, I'm going to copy this command line from the README, and I can just paste it straight into my EC2 instance. And with any luck, we're going to have a look at what happens. So our application fires up. We do some local logging, so I'm going to step you through this logging. And you'll see here that in the first 4 lines of our application logging, we initialize 4 sensors. We define an arbitrary, globally unique ID for each of these sensors. And you'll see here we've got a rain sensor, a temperature sensor, a vibration sensor, and a wind speed sensor. We fire up WebSockets. We're not using it in this application, but we do fire up WebSockets. We fire up our Mqtt server, and then have a look at what we do here, right? We go and we fetch that weather data from that Forecast IO API, and then we attach that sensor and the sensor data to the appropriate city and state, and then we start generating data. And if you have a look at the data that's being generated here on the command line, and I'm sorry it's breaking across lines, but if I go any smaller, people might have trouble seeing. We're generating, for the rain sensor, we generate a sensor timestamp, and that's a epoch timestamp, so what's that, January 1, 1970. We generate a sensor value, so in this case, this time yesterday in Palo Alto, surprise, surprise, beautiful California, no rain, unlike beautiful Melbourne, where it was quite rainy yesterday, and also a direction. When we supply a -1 on direction, it just means that it's not a vector value, so you can ignore it. You'll see here in the temperature sensor, we're generating 60.56, which is the temperature at this point in time yesterday in Palo Alto. I hope that's correct. I haven't checked it, but I'm pretty sure it is. We also generate some vibrational data, and this is measured in Gs in terms of gravity. So this is 0.95% of 1 G, or 0.95 of 1. And then we generate our wind speed and direction as well. And this data will just continue to stream. So that's really pretty cool. We've now got this MQTT data streaming. But how do we actually get to this data? how do we get our IoT devices and applications to have access to this data? There are two ways to do this. The first one is understanding that MQTT streams data on arbitrarily named topics. In the case of this application, the topics that we generate are in the format of weather, / and then the state that you specified on the command line, the city you specified on the command line, and then whether you want the rain sensor, the temperature sensor, the vibration sensor, or the wind speed sensor. So I reckon it's not a complicated thing to draw the conclusion that for California Palo Alto, these would be the topics that the data is being streamed on. So for example, if you wanted to look at the payload of Palo Alto's wind speed, you would see sensor data flow in like this, where this is 0.451 miles per hour and 291 degrees from north. So that's sort of, what's that, northwest? What do you reckon? 291, 270 is west?
I'm not intimately familiar with it.
It's too early here for this complex stuff. But let's push on. So we're streaming data, but how do we get access to it? There are two ways that I'm suggesting here to have a look at this data. The first one is there's a great tool out there called Mqtt Fx, and we're going to look at that. Or you could use mqtt.js. And the README has links to all of those, and you can follow the installations of how to do that. Let's have a look. I'm going to attempt to subscribe to that stream from my local laptop. So what we need to do here is just grab this command line that we've given in the README. I'm going to open up another window here. When my machine decides to listen to me, we can see the data streaming away in the background. I'm going to paste in that command line. The only thing I really need to do here is just change that -h, and that's the host. We're using default ports, so there's no need to change any other configuration. So I can jump back over to my CloudFormation output, and that has the IP address of my EC2 instance in it. So again, Ryan, you're exactly right. The console's really useful for getting data and watching how things progress. So I'm going to change out that -h, and I'm going to drop in my IP address. Now, one of the things I love to do in life is make predictions. It's pretty early, so I'm hoping I'm not wrong, but I'm going to predict that I'm going to start seeing some wind speed data come in that matches the data we see streaming behind. So let's give that a try and subscribe to that MQTT topic. Here we go. How are we looking? Oh, it's not looking good. It's not looking good at all. I would have expected that to have already connected and received some of that data. So what we're going to do is jump across to another tool, which is a bit more visual, and that's the Mqtt Fx tool. Again, it's a free tool. We've got links in the README for that, and it looks, when it decides to load, poor little laptop is having trouble. Here it comes. It looks something like this. What you can do is you can click on the little cog in here. You can pop in the IP address of the EC2 instance and hit OK. And with any luck, I'm unable to connect to the server. And I'm betting that's because I'm on the corporate network. Silly me. Which does not allow me to connect. So I'm going to change that. We'll give my machine a second. And we should be able to receive that data. Geez, you know, Ryan, I told you it was early. I should have checked that before we got started, hey?
I mean, it's 7 a.m. now. You could be excused.
It's not even yet 7 a.m. I've had 3 cups of coffee already. I'm still not quite with it. Let's see how we go connecting to our guest network here in the office. Hopefully that's going to go well. Failing that, I'm going to show you still the same subscription, but we'll do it on the local EC2 instance. So I'm not going to spend any more time on that. So we'll just switch back again to the network. I'm going to reconnect to that EC2 instance because I would have dropped off. Yep. So I'm going to go back. I'm going to look for my SSH command. I'm going to drop back into that EC2 instance. The gods are not with me this morning, Ryan.
I think that the fact that you made it this far without any issues is important.
Oh, your faith in my skills is underwhelming. I'm going to go back and run my generate command, and that's going to get that data flowing again, and off we go. I'm going to open up another window to the same EC2 instance. And remember, what I'm doing here, you can do exactly the same on your local machine, but we do encourage you to use an EC2 instance. Now, as I mentioned before, we just use the subscribe command from our Mqtt tool. But not having thought through that I would need to do this, I may not have installed that Mqtt tool. I haven't. So we're going to quickly install that, and we're going to do that using, let's use npm. So I can install that globally, and I believe it's just Mqtt. Install. Let's do that and install that Mqtt tool. It doesn't like that because I've asked it to be global, so I'll switch to the super user, and I'll run that again. -G means that we're installing this globally, that all users on the on that EC2 instance have access to it, and I'm just going to install that application. And with any luck, I now have a command line tool called Mqtt, and there we go. That's how easy it is. So I'm just going to jump back over here to my command line, and now because I am on that local host, I should just be able to subscribe to that stream. And I'll just make this a bit smaller. Let us know on chat if that's getting too small, but it's just a little bit cleaner to have a look at it like this. Here we go. I have hit enter, and I've subscribed to the wind speed sensor, and you can see here I'm getting a timestamp, I'm getting a wind speed and direction. And that direction is moving around a little bit. I'm not surprised because wind generally tends to do that. But what if I want to get multiple sensor data at the same time? Well, Mqtt allows us to use wildcards within the stream, within the topic name. So I can change out that WS, which was the wind speed, and I can put in a hash. And that means we will subscribe to everything on that weather, California, Palo Alto, Mqtt stream. And you'll see here I'm now getting multiple pieces of data. I'll just stop it so you can see. We're getting some temperature. We're getting, let's have a look here. We're getting some temperature. We're probably getting 0 rainfall. We're getting wind speed, and we're getting a little bit of vibrational data as well. So this is a great way to have a look at all the data that's streaming in from your instance to your application. One of the great things about using Node.js is this code is completely portable onto devices like the Raspberry Pi. So you can install that Mqtt client just like I did on a Raspberry Pi and consume this stream on a Raspberry Pi, and then you can take that stream data and republish that into the Aws Iot service. How are we going for time, Ryan? I've got about another 5 minutes. How's that?
That sounds great.
Great. So you can see here we're generating our 4 sets of data. It's streaming continuously. That's set up at 1 second intervals, which is probably sufficient for weather data. You probably don't want anything faster than that. And we're able to receive the data as well. So if we jump back to our README, you can see over here the links to that MQTT code, MQTT tool, and the Mqtt Fx visual tool. So I encourage you to have a look at both of those. There are some other ones out there that you can use. So feel free to use whatever you're comfortable with to consume that data. So I'm going to jump across and just run everybody quickly in the last 5 minutes through the code and give you an idea around how we've actually built this, because you may want to use this as a prototype for your own work, and you are absolutely encouraged to take this code and improve on it. We are open to pull requests on this code, so if you find bugs or issues, feel free to make the changes and open a pull request. I'd be more than happy to review it and possibly merge it. So what we've got in this application is basically a range of objects that get created for each of the sensors, and we use lib modules sensors for those definitions. So you can see over here we generate a rainfall sensor called rain, which is what's included in the topic. It's called rainfall, and we just create a generic GUID, a globally unique ID, using this device ID hash. So we create a hash which is unique. We create an array of sensors, and then we iterate through that array of sensors to start them up. So we attach a sensor to the weather station. So you can basically view this code as a weather station. So we iterate through that, and then we tell each sensor to start. So, what does a sensor look like? Well, let's have a look at a sensor. So we've got, for all intents and purposes, let me jump down to the, where am I? The definition, here we are. We define a sensor. This is, for all intents and purposes, a base function that are singletons within the application. We've got some valid types. So if you want to introduce a new type, don't forget to update this valid types array. We set some defaults. We check that we're of a valid type. So if you try and define a sensor, I don't know, not vibration, but seismology or seismological, that would not work because it's not a valid type. If you recall, in our in our generate.js, on each of the sensors we call an attach function or method. This is where we attach those sensors to the weather station. We've got some utility logging that you can use here. And then this is how we basically start a sensor. We call start on the method, and then from there we go in, we process the forecast data, and then at 1 second intervals, at frequency intervals, which I'll show you in a minute, is defined to 1. So this is 1 second intervals in this application. We basically publish the data. And publishing the data is actually pretty straightforward. So for the classes that we sit on top of sensors, you can see here we define a frequency. If you want it more, if you want it faster or more granular, you can increase this frequency. It's measured in hertz. And then if you remember before, I said sometimes the data we get from Forecast.io is not granular enough to support the 1 second intervals. So we use some distribution techniques to take the data samples and use a Gaussian distribution across them to spread them out between the samples. And then when we have our process forecast, we basically get the data out, create a distribution curve for that data, and that enables us to create a message on the weather topic, the station name, the sensor name, create that payload that we see. So this payload definition is what you see being streamed over here. This is the payload. and then we stringify that, so we get it as a string representation of a JSON object, and then we give it to the MQTT server to publish. So it's actually really straightforward. Now, if you're running this for more than 24 hours, because we only get 24 hours of data from the Forecast.io API, we just want to make sure that we don't exceed the number of samples that we have. So we loop back to the start, or what I call the publish point, back to 0, so we go back to the start. So that's kind of a very high-level introduction to the code. I encourage you to dig into it and have a look. It may look a little bit overwhelming for those of you who are not used to dealing with Node.js and things like promises, etc. If you do get stuck, feel free to raise an issue in the Git repository. Again, the URL for that is up here. I think Chanda has been kind enough to post it, and we'll be able to answer your questions there. Now, one thing I do want to call out, have a look. We got some sunshine in Melbourne. I've been heads down on the screen, so I haven't been able to see that. Beautiful sunrise in Melbourne. So you've generated a stream of MQTT data that's a nice representation of a whole bunch of environmental data, but what do you do with it? So you can consume this data onto, say, for example, a Raspberry Pi, an Intel Edison, a chip, or any other sort of capable IoT-enabled device. And you can consume this data using that MQTT Node.js tool that I showed you before. And based on that, you can use the AWS Node.js SDK to consume that data and then publish it into AWS. So what I want to quickly do is show you what the IoT service looks like from a console standpoint. So I jump across to AWS IoT. Ryan's going to cover Kinesis, but I'll quickly touch on the IoT service for you. So when you use the AWS IoT service, we really think about it in terms of 3 big chunks of data. Connecting and managing your IoT devices, processing and acting upon the device data, and then the ability to read and set device state at any time. One cool thing about the AWS IoT service is customers like yourselves out there have told us that IoT devices quite often have intermittent network connectivity, and you need to be able to resynchronize state when an IoT device gets disconnected and then later reconnects to the network. So we have this capability called the IoT device shadow, and that device shadow is a managed way of synchronizing state when a device comes back online after an outage or a battery change or even a change out of device. You can manage the device state using the AWS IoT device shadow. So I'm not going to run through how to configure the AWS IoT service, but I encourage you to have a look in the console. It's a relatively straightforward process of how to connect your IoT devices using the AWS SDK for Node or C++ or Java is also not an overly complex task, so I encourage you to go and have a read of that documentation. The documentation is over here. It's extremely rich documentation. Have a look at how you can read this data in that we've just generated from your EC2 instances or your local development environment into your IoT service, consume it, process it, and then publish it into the AWS platform using the IoT service. You could even potentially use the Kinesis service, couldn't you, Ryan?
Yes, you could. I'm actually about to walk right through that.
Exactly. So with that, I'm going to stop prattling on. I'm going to thank everybody for their attention and joining me today. I'm going to hang around to answer some questions. I encourage you all to stick around, have a chat with Ryan. I'm going to disconnect my screen and hand over to Ryan now. So thanks everybody. Again, I encourage you all to clone that Git repository, stand up your EC2 instances, contribute back through pull requests, open issues in Git if you have them or you find bugs, and we'll be more than happy to address them. And I wish everybody great luck with their AWS IoT challenge work, and I hope the information we've provided today has been useful. Ryan, what have you got to share with us?
So thank you very much, Mark. That was a great presentation of the AWS IoT service and working with some real life sensor data. What we're going to share today is I'm going to go through, so Mark just showed how to work sort of like programmatically through the APIs using a set of AWS IoT services. A lot of you may not be familiar with how to use the console or the Amazon command line interface. So we're going to go through basically one example implementation on this AWS Big Data blog post. I'll actually paste it in the chat on how to build sort of an end-to-end solution using AWS IoT, a couple of the Amazon Kinesis products, and Amazon QuickSight to build the real-time visualization. What I'll also do is I'm going to present some alternatives to you guys. So this is like one example architecture, and there's a lot of different things that you can do here. So at each step I'll go through some of the options that you have. It's just as an example. For ingesting data, you can use a Kinesis Firehose or a Kinesis Stream, and we'll talk about whether you would make one choice or the other. But with that, let's get started. So in order to simplify this a little bit, I've got some of the portions already running. But as we go through this, the first thing is how do we ingest data and why do we use Amazon Kinesis? So the AWS IoT provides a very, very good front end for interacting with devices via MQTT. Amazon Kinesis deals with very high volume or high throughput streams of data, which is a very natural fit for IoT devices. So if you're generating in real time, you're generating a lot of very small pieces of data like sensor data. How do I cheaply and efficiently get that data in and process it? And that's really where Amazon Kinesis fits in. So we have a set of services. I'll navigate to the console as I do this. So Kinesis has a set of services. Amazon Kinesis Streams, which allows you to build sort of custom applications and ingest data at a very high volume. Amazon Kinesis Firehose, whose primary purpose is to both ingest high volumes of streaming data as well as load it into a specific destination. So in a very simple solution, if all you're trying to do is get sensors from point A to an S3 bucket or an Elasticsearch cluster, Firehose really fits the bill because it's very easy to set up, and we'll walk through that. And you can do things like transformations before the data arrives, and it's a very good way to set up sort of getting data from point A to point B quickly, cheaply, and efficiently. Kinesis Analytics is the last sort of part of services of Kinesis Firehose. It allows you to run SQL queries on both Streams and Firehose. So this is great if you imagine if you have a stream coming in of data, of continuously generated data points, and you have, say, tens of thousands of data points, and you want to send that to a Dynamodb table, or CloudWatch metrics, or a MySQL database. Obviously, you don't want to write 10,000 events per second to those databases because it's very costly, it's very expensive, it puts undue load possibly on the database. What analytics allows you to do is compute those analytics in real time and load aggregated events into your store or react to it in real time. So an example might be an IoT sensor has particular sensor has a temperature reading that's coming in. The only temperature readings you care about are temperature readings above a certain amount. Analytics will allow you to filter to that and then react to it in real time. So when you guys work on your IoT app challenge sort of solutions, this is one cool thing you can do is get the data flowing from AWS IoT into a Kinesis Stream or Firehose, filter out interesting events, and then react to it in real time, either in a visual way or through an alarm or a metric or through a dashboard. That type of solution is really, really compelling, and that's what we see our customers themselves implement. So I encourage you to try out all three services. We're going to walk through sort of how this solution and show you how they sort of work. So,
hey, Ryan, just a question for you. Kinesis is one of my absolute favorite AWS services because it just makes life so easy. With Kinesis Analytics, if I'm thinking about weather data, I might want to do things like, what was the average temperature over the last 5 minutes, or what's been the average rainfall? Do I need to keep all that state in my application, or could Kinesis Analytics do some of that for me?
So what's great about, and Shaw's 3B, I'm sending you the link to the blog post now, or a mirror of the blog post. Let me get the actual link. Marky, can you help me out there? I think I pasted the wrong link.
Yeah, no
Looks
problem.
like I pasted a mirror to the link of the blog post. So, but to answer Mark's question, one of the great examples of what you can do is Analytics uses standard windowing functionality in SQL, so you can produce metrics in real time over time windows. So, for example, for the temperature thing that we were just talking about, you can compute things like what was the average temperature per device over the last minute, over the last 5 minutes, over the last 10 seconds. And these are simple declarative SQL statements versus doing a lot of the heavy lifting, say, in Java or Python. So that's one of the key use cases of analytics. It's a lot simpler to express some of these types of analytics in SQL other than some other languages. Does that answer your question, Mark?
Yeah, I'm just trying to think around what that means for the AWS IoT challenge. Does that mean that I don't need to run like my own compute to do those sort of things?
Exactly right. Thanks for leading me in the right direction. So Kinesis Analytics is a completely serverless solution. So there are no underlying EC2 instances to manage. We handle sort of automatically reading from a streamer, a fire hose, discovering that schema, and then applying your SQL statements to you, and then streaming that data out of the application. There are good alternatives like AWS Lambda, the Kinesis client library, Apache Spark streaming that you can definitely include in your solution. However, the easiest ones that I'd steer you to are the serverless options because they're just so much simpler to get up and running. So for the challenge, if you choose to use Kinesis Streams or Firehose, I'd strongly steer you to either Kinesis Analytics or AWS Lambda because there is no EC2 instance to stand up or monitor or get included in any scripts or anything like that. It's very simple to get started. It's also simple to iterate on these solutions. So both of them offer an easy way to test via the console. So I'm going to show you a little bit of that. So it's definitely a good approach to sort of get your feet wet with this AWS IoT challenge. Great. So the first step is how do I get data into a stream? And there's two ways I'm going to show you how to do this. And these are both good solutions for basically your development, right? I think Mark's solution that he showed in the very beginning is a better solution for like getting scripts up and running and continuously running. What I'm about to show is while you're in development, while you're testing your applications, some very simple ways to test it, to get up and started, up and running. So the first thing I'm going to go to the AWS IoT service. So if you have nothing on here, Mark just showed that a couple minutes ago, you'll be presented with some various startup options. So I'm connected, so here is actually the startup option. So configuring a device, setting up an AWS IoT button, highly encourage you go down that route. That's a very cool route to go for this challenge. Or you can just get started right away, right? So here, you go through things. You need to register a device, download a connections kit, configure and test your device. So as you go through these options, I'm going to go ahead and click Get Started. Whenever I get started on these IoT solutions, I usually just start my solution from the device being my laptop. So I use a Windows laptop, and I'm most familiar with Python. It's been a while since I did Java or Node. So you'll click Next. You'll choose a name for the device. and then some pertinent information being included. So what are your certificates that you need? How do you write to the device? So on and so forth. You'll be able to download a kit. So in this case, I have a Windows Python kit that I'm downloading. Click the next step, and then it gives you a set of instructions. These are pretty simple instructions, so like unzipping the device and adding a couple parameters. So once you do that, what you'll end up having is you'll have a registered device that is your laptop with an SDK you can start playing around with. So you see, I created one. Go ahead, Mark.
Hey, right. This is pretty cool because if you think about the two parts of what we've discussed today, you've got this EC2 instance running in the cloud, pushing data out. Your laptop could effectively be this thing sitting out there as the collector, right?
Exactly right. So especially if you're, for those of you as part of the challenge that are unfamiliar with a lot of the tools that Mark showed, what I'd recommend is going down this route and building something incredibly simple by hand first, and then going to Mark's template, which will automate a bunch of the stuff for you. And the tools that I'm going to use are primarily just the console and the command line interface, so it's an easy way to get your feet wet in under an hour. So great. So now I have this thing, and there's nothing really associated with it, right? So one of the things that I'm going to associate with it is an IoT rule, right? And rules are very simple to create. I've got one created already, and the IoT console provides a really good interface for configuring these rules. So I'm going to go ahead and click Create. And what's really cool about this is that you get this limited SQL language to apply filters, look at attributes, so on and so forth in here. So in a real world scenario, you can, for specific use cases, you can apply a very fine-grained rules. So let's, as an example, we're going to set up a rule to forward data to a Kinesis Firehose. One of the things you might do is apply a filter on that, which is a fantastic way to just say, I want a portion of my data sent to this particular Kinesis Firehose or Kinesis stream. So the data source is set up, so I finished step one. I'm skipping around a little bit just because I wanted to show you the console. The rule that we're going to set up is very, very simple. So on a particular topic, you're going to set up an action. And the actions available to you are, all of them are very cool. So you can just send a message directly to S3. You can send messages to Kinesis Firehose, like for example, if you wanted to do ETL prior to hitting S3. To SQS topics, if you've used AWS before, you'll see that there's probably a service that you're very familiar with in just ingesting data in. In this particular case, I'm going to send to a Kinesis Firehose. And once I configure this action and set the attributes correctly, basically any data sent to my IoT, sent to the IoT service that meet the specific criteria are just going to be forwarded along to the Kinesis stream or Firehose. I'm not actually going to create it because I've already created it for you. So this is the role, and it's enabled, it's turned on. I'm going to give you guys another sort of best practice that I have while I'm building these end-to-end applications. And that's to use CloudWatch and CloudWatch dashboards very liberally, because it's a lot easier to visually say and verify data is flowing through solution X, data is flowing into and out of solution X. And you can see, as I first started out in this architecture diagram, we're basically building this continuous pipeline. And before I move on to the next step, I just want to verify, is data flowing through it? So there's a great script, sort of short Python script. I'll show it to you real quick. There's a simple Python script that we include in that blog post to get data in that generates some random data. The random data includes a device value, which is SBS01, and then a random number associated with it, a device parameter, so that we have flow, temperature, humidity, a set of device names, and then the client timestamp. So I'll kill this real quick. So I'm opening up my command prompt, and I'm just going to run this script. And what this script will do is it allows me to just continuously generate data from my desktop. And you can see the print right here. Continuously generate from my desktop into the Aws Iot service. And with the rule I just set up, forward it to a Kinesis stream. So I visually see the data is being sent. I want to see the next steps. So how do I do that with CloudWatch metrics? So you navigate to CloudWatch here. So before I do that, make sure I save my dashboard. Navigate to CloudWatch here, go to metrics, and as part of the blog post, they have you name most of the stuff IoT. So you can put some search metrics in there, just search for IoT. You can see IoT metrics, IoT rule metrics. I'll click on IoT metrics, rules executed, and then you want to pay attention to what statistic you're using. So this is average. We want to use sum for most of the stuff that we're doing. And you see this rule is being continuously executed. When I've been running this for a couple hours, the script, you can see I actually turned it off, so it went down a little bit. So data is certainly hitting the Aws Iot service. So great news. The first step I was successful in. The next thing I want to check is, is the rule working? Is it actually forwarding the data to my Kinesis Firehose? So I'm going to go back. And I have some other past work that I have for related IoT things. But the Firehose that I choose to forward it to is an IoT source stream. So you just click on incoming records. And you see it matches very closely to the rule executions. So fantastic. Then I'm going to show you another trick that not a lot of customers know about at AWS. I wish more, because the CloudWatch team continues to iterate very quickly on this feature, and it's really, really nice for real-time dashboards. When you get a graph set up, you can name the graph and then add it to a dashboard. I have a bunch of dashboards that I have related to other test applications. Once you provide a name, you can choose a line graph and click Add to Dashboard. I've started to build a dashboard already for this, and you can see the first graph that I just showed you. I have Aws Iot publishing data and Firehose incoming records. So the data is being sent to Firehose. And I get a great visual view that, hey, my app's running and I'm successfully ingesting data into my Kinesis Firehose. So let's talk about Kinesis Firehose a little bit, why we chose it to start out with. So I mentioned the three services in the beginning: Kinesis Streams, Kinesis Firehose, and Kinesis Analytics. Firehose is one of the simplest services to use of the three. So I definitely, if you haven't touched Streams or Firehose or Analytics before, I definitely recommend you start there. So just getting the IoT data into other AWS services is a really great solution. Streams is also pretty simple, so you can definitely set up your rule to forward to a stream, but I'm going to show Firehose for today. So we're going to go to the Firehose console.
So Ryan, what's the big difference between the two? I always get a little, even though I love these services, I always get stuck about which one do I choose and for what?
That's a great question. So Firehose serves a very broad and simple use case, and it serves it very, very well. And that is, how do I ingest a large volume of small records and get them into my downstream analytics services quickly with very little operations and very, very cheaply? So you're getting a large volume of data events, you need to get them into S3. And when you write data to S3 or Redshift or Elasticsearch, and the destinations that Firehose supports, you want to load that data in a specific way. As an example, the script that we have running right now generates something like 10, 20 events a second. When you upload data to S3, you don't want that data in separate files with very, very small events in it. You want it in nice, large chunks that are easy to deal with it. So you want to buffer the records first, and then possibly transform them before delivering it to S3. Firehose provides that functionality. Firehose also allows you to compress the data before you write it to your destination, encrypt the data before you write it to your destination, and even perform inline transforms before you set it up to a destination. It handles the entire end-to-end scenario without worrying about anything else. So it's a great choice if you're getting data from point A to point B and you need to do it at scale, continuously, with very, very little setup. Kinesis Streams provides a lot more flexibility. What do I mean by flexibility? So similar to Firehose, it'll ingest a high volume stream of data. But dissimilar to Firehose, it provides a lot of different options to consume and process the data in real time. So instead of just delivering the data, you can run a lot of the open source packages that we provide as Amazon Web Services, things like the Kinesis Client Library. You can use a lot of AWS services to consume data off of the stream, like AWS Lambda, Kinesis Analytics, a Spark streaming cluster on Amazon EMR, and a lot of even more options. So it gives you that flexibility. Now with that flexibility, there's a little bit of added complexity. So whereas Firehose completely auto-scales for you, Kinesis Streams, you provision a stream with a certain number of shards or partitions, which gives you a certain amount of throughput. But for the purposes of the IoT App Challenge, if you just create like a 5-shard or a 10-shard Kinesis stream, you'll have so much available throughput, you won't have to worry about scaling the stream up and down. But when you stop operating at scale, that's something you additionally have to worry about it. So where you get increased flexibility, there's a little bit added complexity. But that flexibility definitely allows you to do a lot more things. It gives you more choices to process the data in real time. So I'm going to click Create a Delivery Stream. You can see I'm a huge fan of the service. In one region, I have a couple of them. So the blog post has you create 3 different streams. So a source stream. This is the stream that will ingest data from the IoT service in. And then 2 services that we'll use for process data after we process data from the Firehose. I'm going to go through what it's like to create just one stream to show you, to demonstrate that. And here's a great sort of graphic to show what Firehose does. It ingests a large volume of source data. It buffers that data, gives you an opportunity to transform those records, and then sends them to the destination, your destination of choice. You've got 2 options to get data into Kinesis Firehose. You can directly write to it, which is what we're going to do here. Basically, we're going to forward the data from Aws IoT to a Kinesis Firehose. Or you can just attach a Firehose to a Kinesis stream. So this is when I talk about the flexibility of Kinesis Streams. Kinesis Streams allows you to do, on one stream, attach an AWS Lambda function, attach a Firehose delivery stream that will just archive the data to your destination, and attach the Kinesis Analytics application, and so on and so forth. It gives you that flexibility. With Firehose, you have some options, but you don't have as many options. Pay attention to this bottom part of this screen when you create your first Firehose, because it provides very broadly, Firehose and Kinesis in general, provide a lot of options to get data into the stream. You see here is the example that we're showing right now. But we have a bunch of agents, as well as you can use the Amazon SDKs. You can forward data directly from CloudWatch. There's a lot of good options for getting data into the delivery stream. So I chose the direct put because we're forwarding from IOST. This step we're going to skip, but is a very valuable step. So if you want to transform the data prior to delivering it to the destination, you see step 2, transform records, you can configure an AWS Lambda function to do so. AWS Lambda is a serverless compute option. What it means to use AWS Lambda in the context of Kinesis Firehose is once data is sent from AWS IoT or from whatever data producer you want to a Kinesis Firehose delivery stream, you have the opportunity to transform records using AWS Lambda. So if you want to do any enrichment, want to clean up your records, that type of thing, it's great for that.
So I get confused a lot, Ryan, between miles per hour and kilometers and feet and inches and all the rest. Could I do that conversion here? Could I do that before we write it away using this transform?
Absolutely. The most common things that customers do is for this functionality is to do format translation and then to do field level transformations. When I mean format translations, I mean like going from JSON to protobuf or Avro to CSV records. So different, just simple format translations. Or Apache logs to JSON data, that type of thing. And then secondly, to do like, for a particular column, to like, you might have a Unix timestamp, you want to change it into a SQL timestamp. Or you might have a mile per hour, you want to convert to kilometer per hour. This type of simple computation is great for these inline transformations.
So I could almost use it like a basic ETL?
Yes, exactly right.
Oh, awesome.
Basic
okay.
ETL.
Cool.
So here are your options for delivering data to various destinations. S3, Redshift, or Elasticsearch. For this challenge, you can send it to S3 and pull data from S3. That's a great option. I'd recommend that. Another great option is to send it to the Amazon Elasticsearch service. If you're familiar with that, you can get very rich dashboards and real-time search capabilities with that service. And the fact that Firehose handles the whole ingestion path for you will make the majority of your development effort spent on getting those cool analytics set up. I'm going to choose S3 because we're actually going to use Kinesis Analytics in this flow. So I'm not going to use the Elasticsearch service. You'll choose an S3 bucket. I'm going to just choose a random one of my existing buckets. That sounds good. No prefix. I'm going to click Next. So here's an important, while you're doing testing, there's a set of configurations that you have on your delivery. So if we have a high volume stream of events, and one of the primary value props of Kinesis Firehose is to basically aggregate that data before sending it to it into like larger files. What parameters do we want to send to that? And there are these things called buffering hints that we provide. And it basically says you can provide a certain size and a certain time interval. And Firehose will weight basically the minimum of either one of those to deliver data to your destination. So you can choose extremely large files and like 5 minutes, 6 minutes, 10 minutes, that type of thing. Or you can choose very small files. While I'm doing my development, I always choose the minimum options because I want data to show up as quickly as possible to the S3 bucket. There are I mentioned you can do compression in line, so there's a couple options there. You can encrypt data with your key or a key supplied by the key management service. And you can do error logging. You want to leave this on. The reason being is because if there's any issues with delivering data to, say, your S3 bucket or anything like that, any identity and access management issues, we'll log them to CloudWatch Logs and it'll give you visibility into those issues. You can create an IAM role here. This is a one-click setup, so we'll go through it. It creates the role with the necessary permissions based off of your configurations. Just click Allow. Click Next. And then you'll review everything you have associated with it. So I'm not going to create it. I've already created a Firehose delivery stream. It takes about 30 seconds to create. Once you have the Firehose delivery stream set up and your IoT role set up to forward data to the Kinesis Firehose, and I'm going to go back to the high-level diagram here. Once you have this set up, again, I'm going to go back to CloudWatch because I want to make sure it's working correctly. So you'll go back to CloudWatch metrics. Again, I have the search criteria set up for IoT. I have my source stream that I just created. I'm going to click on that, and you'll see the records start flowing in. You want to refresh it, and you'll see, and then you'll add it to that dashboard. And what you'll get is, click on my dashboard. What you'll get is a graph like this. It's like, okay, I'm successfully ingesting data into the IoT service, and the IoT service is successfully forwarding it to Firehose. The only other thing you might want to check is to make sure that Firehose is correctly delivering data to S3. There's another metric for that, and it's basically delivery success. Or we can choose records. and you'll see they're all about the same. So my entire end-to-end flow is created. I highly recommend you guys start here for the ingestion piece because it's super simple to set up and you can get something working quickly. Go back to my dashboard. So the next thing I'm going to do is I'm going to set up a Kinesis Analytics application. Right? So what Kinesis Analytics allows you to do is read data from a Firehose or a Kinesis stream and then process that data in real time. So you can react to the data in real time, which is quite cool. So I'm going to go to the Kinesis in the console. I'm going to go to Kinesis Analytics. I'm going to click Create Application. So here you see the three parts of what we'll do in the application. So we're going to connect to a source, configure our real-time analytics, and then send data to a destination. So the first step, I'm going to connect to a source, and all of the Kinesis streams and Firehose delivery streams are made available to me so I can select them and get it set up. So I'm going to click on my IoT source stream. That's the stream I created to ingest data from IoT, from the IoT service. Here's an important point. So in the SQL, you refer to the stream basically as source SQL stream. And then the IAM role associated with that, is created for you automatically. So there's an error here. So let's actually just hit refresh, and then we'll get one more time. So it tells you schema discovery successful. So there's an important point here. So Amazon Kinesis Analytics will discover a schema for you sort of automatically, and it works for most JSON and CSV data. If your record starts to get more complex, you might have to edit it by hand. So what I mean by edit by hand is you can click Edit Schema, and from there, you can specify, basically build your schema by hand for specific elements. You may want to do this or modify it as needed if you, like I said, if your JSON structure is quite complex, but for the most part, we'll do it automatically for you. The row path here is basically just pointing to specific elements. And what we're doing is flattening hierarchical documents, so flattening a JSON document. It uses something called JSON path, which basically allows you to index into a JSON document, and then you specify like the SQL column types. So once you have this set up, the next step you'll do is you'll click Save and Continue to continue processing the application. You can see that the data that we're generating, I'll go to my script real quick, data that we're generating here is being sent to the Kinesis service, and we're applying a tight structure to it so we can write SQL code on it. So I mentioned you click Save and Continue here. I'm actually going to click Cancel and move away from it. I actually already have an application that's set up processing data, and I really just want to show you some of the SQL code. So as you walk through that blog post, you'll see sort of an end-to-end application, reading from an IoT source stream, sending it to an IoT destination. There's the setting up the destinations. There's in the blog post covers it how to use it via the CLI, which is great. So I'll show you a little bit of that after the SQL code. But let's just go to the SQL code. So this is the interface for Kinesis Analytics. There's a couple steps in here, but basically the top of what we have here is, and I'm zoomed in, hopefully we can see that. Actually, I'll zoom in a little bit more. The top of the browser shows basically a text editor, all right, with SQL code. It is your SQL-based editor that you'll use to iterate on your applications. The bottom of the screen shows data flowing through your application. So there's a number of templates you can have to get started. All right. So aggregating during a tumbling time window, a sliding time window, applying a continuous filter. I'll walk through sort of what the code in the blog post does first, but there's some other ideas you can have here, and we have a SQL reference guide that you can pull additional examples for. So for the most part, this is standard SQL. There are some extensions that we have. So we read data from an application and we insert into what we call an in-application stream. You can think of this as sort of like an in-memory object. So we're taking the data from the source Firehose delivery stream, and then we're formatting it, and it ends up as our first stream, which is our source SQL stream. And you can see it here, and I'm going to have to zoom out a little bit to show some of the columns. You can see it here. And you can see the 4 columns that we have right here. The device value, device ID, date timestamp, and device parameter. We also add some additional columns. This row time is the time we ingested into the application. So it's basically, there's some underlying nodes that are processing your data. We append a timestamp to them as data flows in. There's an approximate arrival timestamp here. This is when the Firehose delivery stream received the data. And you can see we're processing data in real time, so it happens very, very fast here. So less than a second after the data was ingested from Firehose, it was read into the Kinesis Analytics application. When you write your SQL code, you do so in basically 2 steps. So you create a stream to send process results, and then you create a pump where the majority of your SQL statement lives. So this first stream I have is just a simple pass-through. So I'm creating a stream with the columns that I care about, right? And then I'm selecting from that stream the source SQL stream, and I'm inserting it into that destination basics SQL stream. And it's just a simple pass-through. And from here, you can do things like where device parameter is equal to, say, some filter. So we can choose, say, sound. So I'm going to run this, but right now I just have the basic stream, which is just passing data through, right? So that's the point. So you create a pump, it writes data, continuously reads data, and then inserts it into this target stream that you've created. Before I say that, I'm going to show the second thing. So the second thing I have is a completely sort of independent step. So the thing is, your SQL queries and your steps, they can be run in parallel or in serial. So for example, I could read from that stream, the stream that I just created, that destination SQL basic stream, or I could read from the source stream, which is what I'm doing here. Let me just click enter so it's a little bit easier to read. I'll zoom in here. So here I have a couple of statements right here. So I have the stream that I created, right? This basically defines the target columns, the date timestamp, the highest temperature, and the lowest temperature. And then I have some calculations, right? So the first is the date time. Basically, I'm taking a floor of it, so I'm aggregating on minute intervals. The maximum of the device value as the highest temp, and the minimum of the device value is the lowest temp. And then I'm filtering for the temperatures here. And I'm grouping by a tumbling time window. So this is one way to write a tumbling time window. Another one is this. Another is a step function, all right? There's multiple ways to write it, but what this basically does, and I'll update it real quick, but one of the things that this does is it basically says, over a minute-long interval, aggregate all events, and then give me the max value of the temperature and the min value of the temperature. So let's look at what that is doing. So because I have a minute aggregation, it's going to take a little bit to pull data from it, because data is being outputted every minute. Again, this is the same thing with the Firehose configuration. You want to while you're doing your development, you want to change these values to as little as possible. So I'm going to actually, let's see if something showed up. So yeah, so we got one value with the highest and lowest temperature and that associated date time. I'm going to do the same thing. I'm going to use a little slightly simpler syntax that makes it a little bit easier to use because not all of you might be familiar with floor. So we also have this step function that basically, if you can think about a tumbling window, it steps you through the stream. So you can aggregate on like 10-second intervals or 1-minute intervals, but at the end of that time interval, we compute the analytic and give it to you. So I'm going to choose I'm going to do the same thing up here. And I'm going to actually remove this guy. And then I'll update my application. So I think I intentionally added an error just so I can show you guys the error functionality. But maybe I did get it right the first time. Yeah. So while you're iterating on your applications, we'll produce error codes. And there's a little bit of a lag here on the video stream, so I'll wait. So the error codes that we produce basically show you what was the SQL statement that caused the error, right? And what was the error? So unsigned integer literal 10 column. So you should use a quoted string. So here. We're going to go ahead and add that. So my application was correctly updated. So once the application gets updated, what we'll see is instead of 1-minute intervals of analytics, we'll see every 10 seconds. So again, while you're doing your development, I definitely encourage basically making the interval a lot less, so like every 10 seconds, as opposed to every minute or every 5 minutes or 10 minutes. When you go to publish your application, I might change it to a higher interval. And while our application is updating, I'm going to go back to my dashboard. I have to zoom out just a second. The next thing you want to set up is show sort of in your dashboard is the Kinesis Analytics applications. The blog post has you go through adding a destination. It's quite simple. I'll walk through it in a second, but what you want to look for in your metrics for your dashboard is IoT, and then you'll go to Kinesis Analytics, Application Flow and ID, and you want to choose you want to choose basically input records or input bytes to show that data is flowing in. Uncheck some of these here. And then you want to, when you set up the output, you want to show the output. So data is flowing out. And again, like with almost all of the graphs that we have here, you want to make sure it's sum. So both of them are set to sum. Great. And I like to usually set it to 1 minute. So why is, looks like I have IAM issue setting the data out. So I'll go through and fix that. But what you will notice is as we're ingesting data in every 1 minute, all right, you'll see the amount of data that we send out is a lot less. And what's the reason for that? It's because obviously when we're aggregating things, providing mins and maxes over a 1 minute window, the 60 data points that we are ingesting will turn into one data point that we're writing out. So you sort of see the value prop of Kinesis Analytics. I mentioned earlier that you're trying to write data to a database or anything like that. It definitely decreases loads in the database, as well as if you're reacting to the data in real time. So maybe you're updating a dashboard or anything like that, you're already sending that dashboard or destination process data. So it definitely Instead of having to do the analytics after the data arrives, you're able to do the analytics in real time and reduce all of the load on your downstream system.
That's so cool. And you do all that with no servers.
I agree. It is quite cool. And what's great about this is that it allows you to push your analytics a lot further upstream. So a lot of the customers that use Kinesis Analytics for the first time or using Kinesis for the first time, they're going from getting dashboards that are updated maybe every hour, maybe every day, to getting dashboards that are updated in real time, which is definitely a high value prop. And for IoT use cases where it's so important for those devices to be connected all the time, it's really why so many IoT customers use Amazon Kinesis and Amazon Kinesis Analytics.
That's awesome.
Here's my updated query. You can see the highest temp and the lowest temp. You can also see the output of the date timestamp is every 10 seconds. Right? We do some sampling on the console, as you can see. So sometimes, every once in a while, we skip one. But largely, they come in every 10 seconds. And the data is sent downstream if you have your everything set up correctly, which I don't think I did. So we're going to go and fix that and show you guys how to do that. So I already found the issue. When you go to this destination page, you're going to choose either a Firehose or a Kinesis stream to deliver the process data for. You're then going to choose an in-application stream name. And this is, remember I talked about the streams that you create that are sort of like in-memory objects where you insert process data. You're then going to choose an output format and an IAM role, and then save. So the issue that I identified immediately is, because I'm used to working with this service, is this name is wrong. This is the default name for the in-application stream name, and we don't have any in-application streams named destination SQL stream. I'm going to go back to the application code. You can see these streams that we created. One of them is called destination SQL basic stream. The other one's called destination SQL aggregate stream. So what I did when I first set that up earlier today is I basically set up the destination to read for a non-existent stream. So that was my mistake. I'm going to go ahead and click Edit. We're going to edit that. I'm going to go ahead and copy and paste. Click Check. And then click Save and Continue. And I'll let the application update. So as I do that, I should see in these metrics this turn from zero to either 60 or 6. So when I say 60, the stream that I just pointed to is just a simple pass-through that's not doing anything. It's not filtering records. So it should be about 60 records passing through, similar to here. If I were to have pointed to the aggregate stream, I would see 6. The reason being is because I'm outputting the data every 10 seconds, so there'll be 6 data points every minute. But this sort of illustrates why I use CloudWatch, these dashboards, as I go through my development process, because it helps identify issues. I'm going to go back here, I'm going to ungraph the metrics, and I'm going to make sure that I got the right metrics selected for the Kinesis Analytics application. And what we'll see is CloudWatch takes about 30 seconds to a minute to propagate metrics. So while that populates, output records, there we go. It's quicker than I thought. So you see some. The first minute data point that we have outputted is already showing up. Let's see if it shows up on my dashboard. Yes. Let's actually zoom in. And we'll talk about 1 hour. It looks like I have the wrong metric selected here. So what's great about these dashboards is you can edit them. So make sure I have, remove this metric and add the metric I was just looking at. Great. So 60 because it's the simple pass-through. Fantastic. And my dashboard is updated. So the last thing I want to show you is a way to sort of mock different data very quickly with Amazon Kinesis, and it's the Kinesis data generator. So right now in the past I have this Python script basically running continuously in my browser. This is one great way, and you can modify the Python script that's included in that blog post to sort of match the data format that you want. Or you can use the solution that Mark showed earlier in the broadcast. But another great way to test quickly is this, is the Kinesis data generator. And while that switches, I'm going to provide the link. Sorry about the delay here, guys. So here's the link to the GitHub for the Kinesis data generator. And when you first visit the URL, you'd actually just go straight to the URL. What you'll do is you'll go to help, and you'll click on this, and it'll give you a custom link for your own generator. And all this is a simple website driven off of Amazon S3. This again uses CloudFormation, which we're huge fans of here. And what the data generator allows you to do is allows you to pick a region. So I was using US West 2, which is Oregon, and then pick a stream. So in this, I'll pick the aggregate stream for this case. It then allows you to test at different throughputs. So you can do 1 or 1,000 or 2,000. I usually test with about like 100 or 200, which is why it's sort of the default. And you can see there are these templates that use basically a JS mocker template, mocker tool, a JavaScript-based JSON mocker tool that allow you to generate basically different interesting combinations. Here, I've generated the exact same record, but you can see you can do like random array elements, device values, device IDs, dates, that type of thing, and then test the templates. And the data looks exactly like what we had previously. And then you click Send Data to a Kinesis stream, and the data just gets generated. It's a very helpful tool when you're working with AWS Lambda or Kinesis Analytics. The final thing I'll show you is, I'm going to point to, and I'll link this as well. Another great option to get data into the stream is just to build a data producer yourself. So in our developer guide, there's a great section under Learning Amazon Kinesis Streams on basically how to implement a producer. All right, and you can go through this, and this does stock tickers and shows you a very simple piece of Java code on how to generate data very easily in a continuous manner. The point I want to stress is whatever you guys choose to do for your data producers, and whether you're writing directly to Kinesis Streams or Aws Iot Service, you want to set up something that you can do so continuously, so you can continuously set up, which is why all the tools Mark and I showed today demonstrate that. So with that, we will stay on. I'm done. That's went through most of the blog post. I have data flowing through my IoT rule into my fire hose. I have processed data going in and out of my Kinesis Analytics application. So I've stopped it here. The next part of the blog post is to set up QuickSight to visualize data off of the S3 bucket. But I want to pause before I do that. I just want to do a time check and make sure that we answer any questions about what Mark and I showed today. So do you guys have any questions on the blog post about where to get started, about what approach to use?
Man, you covered a lot, Ryan. My brain's hurting. And you're thirsty.
Does Kinesis integrate with Dynamodb? So It doesn't integrate directly, but that's a very good question. Shaw's 3B asked, does Kinesis integrate directly with Dynamodb? Very, very good question. No, we don't. The most common approaches for you to integrate with Dynamodb are, first, to use an AWS Lambda function. So for example, in this flow, you can attach an AWS Lambda function to a Kinesis stream to write data directly to Dynamodb. AWS Lambda, I'll navigate to the console real quick. You'll click Create Function, and I'm just going to filter by Kinesis because there's a lot of Lambda blueprints. And you want to choose Kinesis Process Record, which is the basic one. And then you'll select your Kinesis stream, the batch size that you want to operate on. 100's a good one, 1,000 might be a better one, but a lot of times I just put the maximum in, or a much larger number. So 5,000. And then the starting position, for test purposes, you want to always choose the latest. For other purposes, trim horizon is a very good option. We'll enable the trigger, and it provides a good example here. And here you can just put a piece of Python code that reads data from the Kinesis stream and writes to Dynamodb. The second option that I point you to is on GitHub. We have a connector. So there's another open source library called the Amazon Kinesis Client Library, which is a library you'll run on EC2. It's also fairly simple to get started. The documentation that I pointed to here, where is it? I lost the link. The documentation I pointed walks through an example of that. We have a connector that'll write to Dynamodb for you. So this will set up a consumer running on EC2 using the Amazon Kinesis Client Library and forward data to these services. So that's another option. I would steer you toward the Lambda option. Dynamo Steve asks, can I run different Lambda functions based on the partition key in a Kinesis stream? So when you when you assign a Lambda function to a Kinesis stream, what happens is that each stream has a set of partitions called shards, and a Lambda function is invoked continuously on a shard. A partition key in Kinesis stream, when you write data to a stream, is a key that you can use to route data to particular shards. So for example, you might use a device ID in an IoT scenario to make sure that the data is evenly distributed across the entire stream. So in a scenario where you have 10 shards and you want the data to be evenly distributed on this stream, you choose a partition key that has a high cardinality between the key and the partition. So in this particular case, the device ID would be a good fit. So to the question, can I use a different Lambda function to read data off of the stream? Because Lambda is triggered on a shard basis, it gets access to the keys associated with that particular shard. There's no way to filter down to the particular key. What customers will do is they'll have logic in their Lambda function to basically read data from the stream and then operate on specific partition keys. Or alternatively, you can use Kinesis Analytics to group data by particular keys, like we were showing earlier, where you group by the partition key, and the partition key is the device ID, for example, and you get analytics based off of the device ID. Hopefully that answers your question, Steve. Anonymous Steve. What other questions can we help you guys out on, both for Mark and I, about how to get started? No problem, Steve. Yeah, I think I'll cover just the IoT challenge again.
That's a good question, Shahaz. You need to be using the Aws Iot Service. So I think provided you're using the service, having to use a physical device is not necessarily mandatory as far as I understand. Chandra, I think you're there. If you want to chime in on chat if I've gone down the wrong path. But I believe you don't need to necessarily use a physical device.
So I pulled up the requirements. So the app must use either Aws Iot or Amazon Kinesis or both. So it can use either. I highly encourage you to use both because it's pretty simple to use both. If you want to just use Aws Iot, for example, to directly send messages to Dynamodb, the question that Autonomous Steve asked, which the Aws Iot service will do, that's one example of you can just using the Aws Iot service. Another example is there's a set of IoT customers that just write directly to an Amazon Kinesis stream or Amazon Kinesis Firehose delivery stream, which is why I showed the data generator and that data producer code of how to just write directly to a stream. That's another option, but I definitely recommend you guys use both. Just because the integration between the two is really, really nice. It's simple to get started, but if you just have a bunch of Raspberry Pis and you want to write directly to the stream, you can.
Yeah, if you do want to use physical devices, again, I would encourage you to use something that is capable of running the AWS SDK. So I would just recommend against going down these extremely low-powered, tiny devices. They tend to struggle to do things like SSL and encryption and all of that good stuff that we would expect in a really quality submission. So if you are going to go with devices, yeah, I'd recommend things like the Raspberry Pi, the Intel Edison, etc. But yeah, as we said, you don't necessarily have to use a physical device. What other questions have we got out there about the challenge that we can help with? Because we've covered an incredible amount of ground today. And I have to apologise, Ryan, I was doing some yawning back there, but it had nothing to do with you.
Maybe my voice is too monotone.
No, you did a great job. You did a fantastic job. I think that really gave everybody some excellent insight into how to integrate Kinesis into their IoT Challenge app. Do you have anything you want to wrap up with, Ryan, or we done?
I think we're good. I definitely encourage you to review the video again. The assets that Mark and I showed are great starting points. I definitely also encourage you guys to use as many AWS services as possible because, or for the use case where it makes sense, rather, because it's just going to be a lot easier to get started. And then the final thing I would say is hopefully we'll do another one of these Twitch sessions maybe in a month or so. But we have an AWS Slack channel. All right, it's on this page. Click here to join. I'm logged in throughout the day answering questions. If you guys have any other questions, we're there. If you guys have tough with development, it's a very easy way to ping us.
Yeah, that's an awesome way to get in touch with AWS. In terms of the stuff that I've presented, again, use issues in GitHub if you're having trouble there, so we can track those and resolve them for you in real time. And guys, the stuff we've covered today is applicable not just to the AWS IoT App Challenge. It's applicable right across your businesses and applicable to a wide array of applications across your businesses. So I encourage you to think not just in terms of the AWS IoT App Challenge, but more broadly across your business, how you can use these services and technologies, how you can transition your businesses to serverless applications, as we've touched on today, and ease the burden of having to run and manage infrastructure as well. So with that, if there are no more questions on chat, we can wrap up. What do you reckon, Ryan?
I think we can wrap up. I hope the rest of your very early day in Sydney goes well, Mark.
In Melbourne.
Or Melbourne.
Don't,
Sorry.
Don't get the two mixed up. They won't let you in on that.
You know, it's because I always think of the region name. I'm sorry.
Yeah, there you go. There you go. All right, everybody. Thanks so much for joining. Good luck with your AWS IoT App Challenge, and we will see you in the future. We look forward to doing another one of these and helping you along the path.
Bye, everybody.